Alright, okay, so hello dears. Ayan, so welcome now again to the continuation of our pre-recorded lecture on stool concentration techniques. And for this lecture, we're going now to start with the last type of your concentration techniques, which are your sedimentation methods, okay, or sedimentation techniques. Now, sedimentation. Naulog siya, okay? Yes, mga memes lang guys, para funny naman konti, para okay, alright. Now again, the difference lang with the technique, or with the principle is that sedimentation. By the name itself, parasites this time are much dense. So they are now denser than your fluid, okay, the fluid surrounding your parasites. So because they are much denser, they are heavier this time, therefore they will sink. And they will be recovered at the sediment below. Therefore, that's the name, sediment. Okay, so we examine now the sediment. Okay, so we don't examine now the surface, we examine the sediment. Okay, because again of the principle or the rationale that the parasites are much heavier this time than the reagents used, therefore they now settle at the bottom. Okay, so we then recover them from your sediment. Okay, after centrifugation. The reagents, as mentioned, they have now lower specific gravity, and therefore your parasites have higher. The parasites have the higher specific gravity. So same principle, higher specific gravity, meaning much dense, they are much denser, heavier, so therefore it will sink. Okay? Compared to the reagents, the fluid used or the fluid around the parasites, which are much lighter, or they have lower specific gravity. Therefore, again, the parasites, it will now facilitate the settling or the sedimenting, the falling, the falling of the parasites to the bottom, to the sediment. Okay. All right. Best technique for the best technique for, for these eggs. So as you can see, they're all quite heavy eggs. Okay. So medyo mga mabibigat sila, mga bigaten. Okay. All right. So schistosoma, operculated eggs of your trematode, mga trematode eggs, cestode eggs, and trichuris and your capillaria. Why? Because again, they are heavy eggs because they both contain bipolar plugs. Okay. So the bipolar plugs make them heavy. Okay. All right. And again, we have different methods. You have simple gravity, you have acid ether, you have formalin ether or ethyl acetate, and lastly, methylate iodine, formalin ether or methylate iodine formaldehyde concentration technique. Okay, all right. So we'll start first with the first one, which is simple gravity. So with the name itself, very simple. The procedure lang is you have a stool. Okay, so in a tube, you put your stool, you add tap water, okay, and then you mix, and then after a while, you then allow the parasites to settle down by gravity. Okay, so after mixing, diba, so ma-mix na ni sila, okay, so you let it stand, and then of course, the parasites will then fall by gravity, and then you examine the sediment. Very, very simple, okay? So you don't need any additional reagents. But, precaution lang, schistosoma eggs, they will hatch quickly in tap water. So in order to prevent that, we add NSS or your normal saline solution to prevent hatching of your schistosoma eggs. Okay? And you could also add glycerinated water, which is 0.5% glycerine in tap water because it enhances the settling or the sedimentation of your parasites. Okay. All right. The sediments can also be preserved in 5% formal saline or 10% formalin. Advantages is minimal use of glassware reagent, as in you only need a test tube and tap water. NSS also can also be used to prevent hatching of your schistosoma eggs. So very, very minimal use. Very cost effective. It's not that expensive. Okay? Useful again in cases of schistosoma, strongyloides infections because they will settle at the bottom. Your larvae of your strongyloides, and also schistosoma eggs because they're heavy. So they will settle at the bottom. Sediments are useful for study and future references because, again, they can be preserved either with 5% formal saline or 10% formalin. And lastly, it allows the settling of cysts, eggs, and even larvae. So you can recover a lot of the sediment. Okay, but for the disadvantages, because again, you don't need any parang reagent that could remove your fecal debris, then you could have a lot of fecal debris that is included in your sediment. So it could hinder your examination, it makes your examination difficult. And aside from that, it's time consuming because you wait for everything to settle at the bottom. So it could take a lot of time. Okay? All right. So that's for simple gravity sedimentation technique. Okay. All right. For the next one, you have your acid ether concentration technique. So same principle, but this time we then use a lot of reagents na. Okay? All right. So we use now hydrochloric acid. And what is the purpose of hydrochloric acid? It dissolves albuminous material. So the different mga other fecal debris, yes, mga fecal debris in your stool sample. So using your acid, hydrochloric acid, it dissolves those material. So meaning rendering your preparation much cleaner, okay, or free from the fecal debris. Okay. Recommended siya for the recovery of trichuris, capillaria, and schistosoma. Still mga heavy eggs. So, mga mabibigat ng itlog. Ang basta. Alright, okay. Method of choice if the stool comes from animals like cats and dogs. So, if you want to look for mga parasites na dogs ninyo or cats, if they have parasites, but then you could use this concentration technique. Okay, disadvantages lang, loss of parasite to the plug of fecal debris. Yes, there could be, di ba, we want to separate the fecal debris, then there could be parasites that could be included there. So pagtanggal natin sa fecal debris, they could be included sa pagtanggal, okay? Possible destruction of protozoan cysts. Either is flammable and explosive. Yes, very flammable and explosive. That is why we can use also ethyl acetate, but the difference lang is ethyl acetate is less efficient in the extraction of your fecal debris, mga fats or mucoid material. So, yeah. So, medyo naadya po yung mabilin. There can still be little amounts of mga fecal debris that remains in your solution. Okay? If you use ethyl acetate. Alright. Okay. Now, for the reagents, ayan. So, still quite the same. I just highlighted again the parang unique to it. You have again either ethyl acetate. Again, its purpose is dissolve neutral fats and lipids and even carbohydrates and stool. So that's the purpose. Okay, so that again, still the main goal is to remove as much as fecal debris possible. There is. To remove as much fecal debris there is. No. Okay, all right. And 40% hydrochloric acid, okay, which again dissolves your albuminous material. Okay, all right. Now for the procedure, first is of course in a tube ba to? Yeah. You add 5 ml HCl, 5 ml 40% HCl, okay? And you emulsify 1 gram, the size of a thumb, so the size of a thumb na stool, okay? So emulsify, so you mix, okay? Next, this suspension, you put in another tube that has a 1 layer of gauze. Sorry guys, I don't know how to draw, okay? Again, the main purpose of gauze is for straining, to remove mga bigger debris sa stool, okay? All right? And after you, di ba, after you strain, okay, you add, okay, 3 ml of either, and then you also add a stopper, okay, all right, and then you shake vigorously for 1 minute, and then centrifuge for 2 minutes at 1,500 RPM. Now, with a clean applicator stick, we loosen the interspace film at the acid ether junction, and then the layers are poured off. I have a picture later para mas clear. And then we shake the sediment, okay, and then get 1 drop, put it on a glass slide, and then examine under the microscope. So these are and report the number again of parasites seen per cover slip. Okay. All right. Now, this is the layers. Ayan. So you have here the ether layer, the interspace film, the acid layer, yes, and you have the sediment. So what do you mean by number 4 is using a applicator stick, we then loosen this, okay? All right, using an applicator stick, okay? So you insert your applicator stick in the tube and then you loosen, okay? You loosen it here. You loose the plug. These now contains mga debris, okay, other unwanted materials. Now, when this loosens, the layers here combines, okay? So what happens is we decant that, okay, bottoms up, all right, bottoms up, decant everything. And then what we now have is your sediment, okay? All right, and then we shake the tube a little because there could be some fluid pa na iwan, fluid that remains at the side of the tube after you decant. So the fluid now resuspends, okay, the sediment, so you mix, and then you get 1 drop of the sediment and examine under the microscope. Okay, 1 drop, put it in a glass slide, cover slip, and then examine under the microscope. All right, so that's for acid ether concentration technique. Okay, all right. Now for the next method, we have your formalin ether or ethyl acetate concentration technique. Now this technique is considered to be the most widely used concentration technique. And it's also the technique that we will perform in the laboratory, okay? All right, in our class, okay? Most widely used sedimentation technique. So we have the main reagents. You have formalin, which serves as your fixative, again, for preservation. Ether, again, which dissolves neutral fats, lipids, and carbohydrates. But again, it's explosive and flammable. That's why we can use ethyl acetate, which is alternative for ether. Okay. Now, again, it's useful in the recovery of both helminth eggs and protozoan cysts. Can also be performed on formalin-preserved or PVA-preserved samples or even fresh stool samples. More parasites, however, can be recovered from formalin-preserved samples, and the morphology is also better in formalin-preserved samples than PVA-preserved samples. Okay. Sediments can also be stored for a long period of time, but the disadvantages similar to your acid ether. So, could be loss of parasites in the fecal plug. You have also destruction of protozoan cysts. And aside from that, ether is also flammable and explosive. And ethyl acetate, less efficient in the extraction of the fecal debris. All right? Okay. Yeah. Now, for the materials and reagents, still the same. So, ether, ethyl acetate, and your 10% formalin. All right. Now, for the procedure, the first thing that we do is in a container, all right, you put your stool and you add 10 ml of 10% formalin. Okay. So, maraming 10. 10 ml, 10% formalin. And then what we do is we mix, okay? Mix it. All right? And then let it stand for 15 to 30 minutes for fixation to occur. Because again, it's important because through fixation, diba, preservation of morphology, the distortion of protozoan cysts is reduced. Okay? So, dili kayo ma-distort. All right. Now, after, still the same, we strain this suspension in 2 layers of gauze. Okay? So, we add it here. All right? So, you have now a liquid with your stool sample. Okay? So, the next thing that we do is we centrifuge this emulsion. Okay? Centrifuge the formalin with the stool, diba? So, we centrifuge. And again, after centrifugation, you then get a sediment, diba? And the supernatant. Okay. Now, what we do is we discard the supernatant. Okay, discard. And then the next thing that we do is we wash the sediment by adding now tap water. And how many times do we do that? 3 times for washing. Baka ibang washing alam nyo, charot. Okay, so washing. So add tap water, mix, spin, centrifuge, decant. Okay, until the supernatant is clear. Okay, all right. It means that the fecal sediment is now clean. It's free from any debris, or to further, clean it from the fecal debris. All right. Okay. Next, after the remaining fluid sediment after washing, we then add another 3 ml of 10% formalin and then stand for 5 minutes. And then after, we add ether, okay, cover with a rubber stopper, spin the sample now at still the same 1,500 to 2,000 RPM for 5 minutes. We decant the ether, tangtangon Japon, or remove the fecal debris, and then again, leaving you with the sediment. So to understand better, here's a picture of the layers. Very important that you take note of the layers, guys. Lumalabas sa boards. So you have the ethyl acetate. This is after centrifugation. You have the fecal debris and you have the formalin. So what we're after is this one, okay? So again, still the same with acid ether. Using applicator stick, you loosen this area, okay? Okay, you loose, diba, tube. You put your stick and then you loosen, all right? So when you bastos na. When you loosen, okay, so all of the layers at the top will combine, okay? So you then dispose, decant, okay, and you're left with a sediment. Okay, so again, shake a little so that the fluid that remains on the side of the tube, yes, on the wall of the tube will resuspend the sediment. Okay, and then again, the next procedure, mabilis, yes, sediment remaining, mixed thoroughly, all right? Tapos, okay, mixed, and then you get 1 drop, put in a glass slide, put cover slip, and examine under the microscope. Or you could also use 1 drop of the sediment preparation, and then you add iodine. Okay, so to stain your protozoan cysts. Okay, so that's now a concentrated, it's now called a concentrated saline, ayan, wet preparation, or iodine, if you use iodine. Okay? All right, so you could examine it directly, 1 drop from the sediment, or you could add iodine, so again, to stain your protozoan cysts. All right. Now, for reporting of results, still the same, similar with your direct fecal smear. If protozoa, positive for, example, Entamoeba histolytica cyst. If negative, none seen. And again, for helminths, number of eggs. So, 57 Trichuris trichura eggs seen per cover slip. And if parasites are absent, none seen. Okay. So, that's for formalin ether ethyl acetate concentration technique. Again, the most widely used, most commonly used sedimentation technique. Okay? Nako, press the buzzer. All right, okay. And the last method for our sedimentation methods or techniques are your merthiolate iodine formalin ether concentration technique or merthiolate iodine formaldehyde concentration technique. Okay, so again, this is recommended for the better identification of your protozoan cysts. Why? Recall MIF, merthiolate iodine formalin. Diba, merthiolate and iodine, they can serve as a stain. Okay, so they stain now the protozoan cyst. That's why it's better for identification of protozoan cyst because there's a stain, there's a color. You can color already the protozoan cyst. Sa reagent pa lang. All right? Okay. Main reagents again, formalin fixative, either still the same purpose with the rest previous slides, and lastly merthiolate and iodine, which serves as a stain. Okay. Materials and reagents, still the same. Difference lang is Lugol's iodine. And aside from that, this is the procedure. Again, you add potassium iodide slowly, all right? And also you add iodine crystals. You store in a brown bottles to protect it from sunlight. Okay, para di siya mo-deteriorate so that your reagent will not deteriorate from sunlight, from exposure to sunlight. Okay, all right. And aside from that, you also need an MIF solution, so stock merthiolate formaldehyde solution. This is the composition. And again, you add a thimerosal or tincture of merthiolate because this will now contains the eosin, which stains the protozoan cysts aside from the iodine that was included. So a lot of stain are there. So much easier to identify protozoan cysts because again, you stain, you give color to your protozoan cysts. Okay. All right. Now for the procedure, still the same naman. Actually, for concentration techniques, same procedure, most of them, no? Difference lang ang mga reagents and mga modifications in the procedure. But generally, they have the same, no? They have the same parang methods talaga. All right. Now for MIF, you add test tube, you add 8.4 ml of the stock solution, okay, that you have already prepared. And then you also add 0.6 ml of iodine, Lugol's iodine, okay? Iodine. Okay. Next, you add a 1 ml of your fecal specimen preserved in formalin, yes, pa rin. Then you stir thoroughly. So you add your specimen here, okay, liquid pa rin. Stir thoroughly, shake for 5 seconds, and then you strain through 2 layers of gauze into a centrifuge tube. 4 ml of either na pod, you have the stopper, and then let it stand for 1 minute. And after a while, you centrifuge for 1,600 RPM. So siya ang difference na RPM. And then you'll see a 4 layers na tube na ma-form. So still the same, loosen the fecal plug and then decant, decant, and then you're left with the sediment. Okay, so example. And then pipette a drop of the sediment on a glass slide, place a cover slip, examine under the microscope, and again, report the number of eggs seen or protozoa if naaba. Okay, so again, still the same layers. You have the ether, you have the fecal layer or the fecal debris plug, you have the MIF layer, and of course the sediment. So still the same, using an applicator stick, you loosen this layer, okay? So when you loosen this layer, it will now combine the 3 layers, no? And after a while, once ma-combine na, you then decant the liquid portion, and you're left now with the sediment. And this is now, again, what we examine. Pipette a drop on a glass slide, place a cover slip, and examine under the microscope. All right. And that's it. Okay. That's the end of our concentration techniques. No, medyo marami-rami naman. But again, those are another type, di ba? Sorry guys, wait. So again, di ba, I think I've mentioned in our preparation of fecal smears, according to Bailey and Scott, your concentration techniques is the second part, di ba? The second part of your ONP, ova and parasite examination. And we usually call this part the indirect wet mount. Why indirect? Because again, your stool sample underwent concentration techniques. you didn't get it directly from the stool sample and then examine. You have already undergone or you have already subjected your stool samples to a lot of reagents already for concentration. That's why it's an indirect wet mount. So this is the second part, diba, of your ONP examination. That's according to Bailey and Scott. All right, so again, those are the methods for concentration techniques, no? Flotation and sedimentation. I hope you got the difference lang. By the name itself, flotation, parasites will float because they are less dense, they are lighter than the reagents used, all right? And in contrast, sedimentation methods, they sink because they are much heavier this time than the reagents used. Okay, so you recover from the sediment at the bottom, all right? Those are, again, concentration techniques. Very, very important that we perform concentration techniques, especially in light infections, meaning infections that can lead to our false negative reading of direct fecal smear. Light infections mean that, again, the number of eggs, of the parasite eggs that can be found in the stool sample could be little pa. That because it's too little, no, we can miss, no, we cannot see the parasite eggs, or we can miss the parasite egg when we examine it under direct fecal smear. Okay, so that's the importance of concentration techniques. And aside from that, concentration, by the name itself, you concentrate, you aggregate, you accumulate, you gather all the parasites that can be found in the stool sample, and with less fecal debris in examination. That's why it's much easier and much accurate to perform. Okay, and you can identify the parasites easily also. All right. Okay, so that's all again for concentration techniques. I hope you understood our lesson. Sana naman, I hope. Okay, but again, if you have any questions, do not be shy. Nako, malapit na matapos ang SEM but you're still shy. No, don't be shy na, guys. Okay, dapat mga checka na lang tayo. Okay. Again, don't be shy. Feel free to chat me or chat in our group chat for your questions, okay? And I'll see you on our next pre-recorded lecture, guys. Thank you so much for watching, and keep safe and have a great day. Thank you.